Good day. You are welcome to Biochem Science Hub, where we treat science-related subjects such as mathematics, chemistry, biology, and physics. So today we'll be looking at that important topic in chemistry, electronic configuration. So electronic configuration, there is no how you want to understand electronic configuration without not understanding your periodic table. Without not understanding your periodic table. So at the end of this lesson, what are the things that we are going to learn? So number one, you are going to learn how to fix each element into periodic table. And the second thing you are learning, you are going to learn which group each element belongs to in the periodic table, and also in which the third thing is the in which period does this element also belong to in the periodic table. And also the additional bonus is that you are going to learn in which element, two elements, why how can you determine that these two elements or three or more elements belong to the same group or they belong to the same period. So practically before we begin, you have to understand what is period and what is group in periodic table. Starting from group. Group is the vertical arrangement of elements in the periodic table. So it's the vertical arrangement of elements in the periodic table, while the period is the horizontal arrangement of elements in the periodic table. So we have group 1, group 2, group 3, 4, 5, 6, 7, group 8. Our group 8 is also known as group 0. So fixing our first 20 elements into this period, let's go. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. So we have our first 20 elements in here fixed. So this is we have group 8 and we have period 1, period 2, period 3, and period 4. Don't forget we said the horizontal arrangement of elements is called period in the periodic table. So before diving fully into the electronic configuration, we have to understand that there are some scientists that contributed their own quota to this topic before being possible for every one of us to learn it today. The first scientist is called Niels Bohr. Niels Bohr, in year 1913, Niels Bohr really worked on the fixing of electron into different energy level, and later in the year 1920, distributing the electron into various group into the various shell that we have. So that's Niels Bohr. And the second scientist that we have here is Charles Bowie. Charles Bowie in year 1921. Charles Bowie worked on the distribution of the electron into successive inner and the outer shell. So limiting electron to the to certain energy level or certain energy number. And the third scientist that we have is Edmund. It's called Edmund Stoner. Edmund Stoner in year 1924. So Edmund Stoner really worked on the rules that we are using now to distribute elements into periodic table. The rule of 2n2. So Edmund Stoner worked on the precise quantity-based method that we are using for the periodic table now. So likewise, so we have shell, we have shell number, and we have maximum number of electron, So maximum number of electrons 2n raised to power 2. Our shell number basically referred to as n. So starting with shell, we have K, L, M, N, O. So shell number for K is 1, for L is 2, for M is 3, for N is 4, for O is 5. So how do we calculate for our maximum number of electrons in each shell? So that's the formula by Edmund Stoner. So and that one, you just substituted your what? Number of shell into this formula. So when we have our n equals to 1, that's 2 into 1 square. 1 square we already know that's what? 2 times 1, that's 2. So when n equals to 2, so we have 2 into bracket 2 square, that's 2 times 4, that's 8. So when n equals to 3, that's 2 into 3 square, that's 9. 3 times 3, that's 9. 9 times 2, that's 18. So when n equals to 4, we have 2 into bracket 4 square, that's 4 times 4, 16. 16 times 2, that's 32. And we have when n equals to 5, that's for shell O. So that's 2 into bracket 5 square. 5 square, that's 25. 5 times 5 times 2, that's 50. So fixing the maximum number of electrons now, let's go. That's 2 for L, 8. For M, that's what? 18. For N, that's 32. And for the last part of the shell O that we have here, that's what? 50. So we have to understand that. I want to understand that. So what we have to look next. So what we have to look next is fixing of what? Fixing of first 20 elements and there was corresponding electronic configuration. So we have hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. So starting with hydrogen. Hydrogen is what? 1. Helium, 2. Lithium, 2, 1. As we have maximum number of electrons in K is 2, then it will move to the what? L. Beryllium, 2, 2. Boron, 2, 3. Carbon, 2, 4. Nitrogen, 2, 5. Oxygen, 2, 6. Fluorine, 2, 7. Neon, 2, 8. Hope you are following. Sodium is 11 in the periodic table. That's 2, 8, 1. Magnesium, 2, 8, 2. Aluminium, 2, 8, 3. Silicon, 2, 8, 4. Phosphorus, 2, 8, 5. Silicon, 2, 8, 6. Fluorine, 2, 8, 7. Argon, 2, 8, 8. Potassium, 2, 8, 8, 1. And calcium, 2, 8, 8, 2. So this is the electronic configuration for the first 20 elements. And don't forget, as in the beginning of the video, we said how do we determine if 2 elements belong, or 2 or 3 or more than elements belong to the same group or period. So here is the trick. So when you have elements with the same outermost shell number, like now we have outermost shell number, this one has 1, that is the last number on their electronic configuration. That's what we mean. And you have lithium, isn't it, 2? And we have sodium, 3, and we have potassium. So all of these four elements, they possesses what? They possesses one in their outermost shell. So if you look at the periodic table that we have here, see hydrogen, I told you lithium, isn't it? And we have sodium in the same group, and we have what? Potassium. I told you in the beginning, this topic very easy. Chemistry is very interesting subject. And also let's look at group 2. Group 2, so we have helium, we have, no, we are looking at group 2. We have beryllium, let me spell it that, and we have magnesium, and we have calcium. So they belong to the same group. And if you look at, let's look at group 7. Group 7, that's fluorine and chlorine. You look at fluorine and chlorine, they have what? Fluorine and chlorine, they have 7 in their last outermost shell. So that's to tell you that what? They belong to the same group. So to group 1 now, our first 20 elements, group 1, we have hydrogen, lithium, sodium, and potassium, isn't it? Group 2, so we have beryllium, we have magnesium, and we have calcium. From our group 3, those are the ones that possesses 3 in the outermost shell. We have boron, we have, what else has 3 there? We have aluminium. And if you look at group 4, so we have carbon, and we have silicon. And group 5, in group 5, we have nitrogen, and we have phosphorus. Group 6, what do we have in group 6? We have oxygen, and we have sulfur. So group 7, in group 7 we have fluorine, and we have chlorine. So fluorine and chlorine belong to the same group of called halogen. Group 8, we have beryllium, so as neon, and we have argon. Those are inert gases or noble. So we are able to tell which group each element belongs to using the what? Using their electronic configuration. Now, how do we determine if they belong to the same period? We have looked to determine how they belong to the same group. So to determine where they belong to the same period. Here is the trick. So we have 281. For which element is this? Sodium. We have 287. For which element is this? Chlorine, 17. You have 282. Magnesium. So if you count the total number we have here, we have 1, 2, 3, 1, 2, 3, 1, 2, 3. So which make them belong to the same period. So to tell this one, the 3 of them belong to the same period because they carry the same number 1, 2, 3. So that's how to determine it. So like now, from our work that we've done here, if you look from lithium to neon, you see they only have 2 digits: 21, 22, 23, 24, 25, 26, 27, 28. You see they have the same number of digits, which is 2. So which means they practically belong to what? Period 2. And if you look at here, period 1, period 2, lithium to what? Neon. I've told you, easy. And also, if you look at sodium till argon, they have 3 digits each. Sodium to argon, they have 3 digits each. So 281, 282, 280, 284, 285, 280, 287. So when you get to potassium, you now have 4 digits, which is 2881, making it what? 4 digits. So they don't belong to the same group. So this doesn't belong to the same period because it has 4 digits, this has 3 digits. So if you count the total number of digits in your electronic configuration, so you'll be able to determine this element belong to the same group with this element. That's how the same period with this element. That's how to determine by counting the total number of your what? By counting the total number of your what? Electronic configuration. So if you have 3 digits, that's group 3. If you have 2 digits, that's period 3. If you have 3 digits, that's period 3. If you have 2 digits, that's period 2. If you have 1 digit, that's period 1. In your hydrogen and helium, just 1 digit, that's period 1. And if you have 4 digits, that's what? Period 4, 1, 2, 3, 4, which means potassium and calcium belong to the same period. So like now they can tell you an element X of 2887. 2887. They will now ask you which period. So to find the period, ask you to find the period, and they will ask you to find the group. Which period does element S belong to, and which group does element S belong to? So to find the period, we've already told us that just by counting the total number of the digits that you have in your electronic configuration. 1, 2, 3, 4. So we have 4. It belongs to period 4. And how do we now determine group? Group, that's the last digit number, the outermost shell. I told us that 7. So group 7. Easy. Very, very easy. As I've told us, that's the trick on how to use your what? How to use your electronic configuration to determine your period group, and also how to fill in the what? In the periodic table. I hope you understand it. Or if you have any question, kindly drop the question. And if there's anything that you don't understand more, kindly ask us. And also, if you have not been following this channel, kindly click the subscribe button by following Biochem Science up. I hope you understand. See you in the next.